Okay, year 11, here are some worked examples for some revision question for this topic. First of all, increase 275%. Best way to do this is we're going to say $270 times, now we're increasing, so I need the 1. It's going up, plus, now 5% is 5 over 100. So if we write it like this, 270 times 1 plus 5 over 100, I grab my calculator. Right, we're going to type that in. Let's just get this over here. 270 times bracket 1 plus 5 over 100. Oops, not like that. Like that. Okay, equals should be a little bit more than 270. Right, I've got a fraction there, so I'll just press this FT button, fix it up, and I get 283.50. All good? Excellent. 1B, Lily's wage increased by 10% last year and 15% this year. Express the total change as a percentage. What we need to do to begin with is to put in a dummy figure. We're going to start with 100. Right, let's start with $100. So I'm going to write 100. Now I'm going to increase that by 10%. So that's times bracket 1 plus 10 over 100. Right, that's increased by 10%. Then I take all of that and increase that by 15%. So that's times 1 plus 15 over 100. Okay, that's going to start with 100, increase it by 10%, and then increase that by 15%. And what I'll have at the end, right, out comes the calculator again. Here's my calculator. Okay, by the magic technology, I've put that expression into my calculator now and I press equals, and I get a fraction, FD, right? 126.5. Now, considering I started with 100, it's gone up to 126. I could work out the difference between those numbers and divide it by 100, but you know what? That's just 26.5%. So we have a 26.5% increase. That works because we used 100 there as the dummy figure to begin with. We could call it 100%. 26.5% increase. It's really important to use the word increase. Okay, because maybe we've got a mix of increase and decrease. We want to know the change. It's not just the percentage, it's also the direction. Righto, let's look at question 2. Okay, question 2A, $22,000 invested 4 years at 3% per annum, simple interest. How much interest is earned? This is sort of as direct a simple interest question as we can be asked. So, I think it quite helps to write over the question. My principal, P for principal, is 22,000. N, my number of terms is 4 years. And my rate of interest is 3% per annum. Okay, I don't have to modify any of those. Everything's in years. So remember, our formula is interest equals PRN. You don't have to write your formula, but you do have to write your substitutions. So my interest equals 22,000 times 3 over 100. B, that's my R, times N is 4. My interest equals, again, out with the calculator, 22,000 times 3 over, oops, oh, don't worry about that, 3 over 100 times 4, oops, made a mistake there too, need to go across times 4, okay, equals $2,640, boom. So my investment of $22,000, my principal of $22,000 has increased by $2,640. And that's all I wanted to know was the interest. If the question said, what is the value of my investment now? Then I would add that on to the $22,000, but it didn't say that. So there we go. That's 2A done. Righto, question 2B. What flat rate of interest is earned if this investment grows to this over 5 years? There's all sorts of complications here. Now remember, interest equals PRN. Flat rate is our clue that it's simple interest. This is my principal, that's fine, that's what I start with. N, my number of years, is 5, that's all good. But what's this here? This is not my rate, right? I'm trying to find the rate. So R equals some unknown, but this here is not my interest either. Okay, this is the final amount. So first of all, I'm going to say that my interest is equal to what I finished with minus what I started with, which is equal to $5,000. Okay, so now I've got the interest. Now we're going to substitute into our formula, and I'm going to say that 5,000, remember interest equals PRN, so 5,000 equals 20,000 times some unknown rate times my N of 5 years. I've got this, I can tidy that up a bit and get 5,000. Now 20,000 times 5 is 100,000. 100,000 times R, that means that R, rearranging things, divide both sides by 100,000, I get 5,000 over 100,000. And you know what's easy here? Scrub off all of 3 zeros off the end of those. R equals 5 over 100 is 5% per annum, right, as a flat rate of interest. That's B. That's reasonably complicated, but we just work out. We've got the formula, I equals PRN. We need to find out as many of those things as we can to begin with, substitute in, and then solve the resulting equation. Okay, we've got a compound interest question here. $49,000 invested 11 years at a rate of 3.3% per annum, compounding annually. Now that's the thing you want to see with these questions. Compounding annually means that you don't have to modify, probably, most of the information you're putting in. My principal is here. My number of terms is here, is 11. Right, don't have to change that because it's years and years. My rate of interest is here. And I want to know the final value. Right, that's A that the formula gives us. I don't have to subtract the principal to get the interest or something like that. So our formula, A equals, that's P, 49,000, outside of 1 plus R, 3.3 over 100, 1 plus R to the power of N to the power of 11. Calculator is going to work that out for us. 49,000 times bracket 1 plus 3.3 over 100, arrow across here, to the power of 11. Okay, that matches up there, and we get 70,032.50. Okay, does that seem about right? It's more than 49,000, but not preposterously more. Okay, that's 3A. Let's have a look at 3B. And 3B in a lot of ways is very similar to 3A, however, it's much more complicated. Now, the real complication is where it comes in here, where it says compounding monthly. Okay, that means that, right, my principal doesn't change, but N, it's not 11 years because I'm not compounding it 11 times. I'm compounding it 12 times per year, so is 12 times 11 equals 132. Okay, that's the start there. N is 132. Also, my interest rate there says per annum, but I'm not compounding it annually, I'm compounding it monthly. So my R is 3.3 over 100 all over 12. That's what R is going to be, because we've been quoted an annual figure when we are compounding it monthly. And finally, I've also says interest here. We'll get to that at the end. Right, back to our formula. A equals P outside of 1 plus R to the N. So 49,000 outside of 1 plus, now look at this messy thing, 3.3 over 100, right, over 12 to the power of 132. Okay. So A equals, out comes the calculator, 49,000 outside of 1 plus 3.3 over 100. I think I need to put brackets around there. Bracket there. I'll say over. Yep, that works nicely. That looks right. Just make sure that the 1 isn't part of the numerator there. Right, close that bracket, and to the power of 132. You've got to make sure you type that in to calculate correctly there, because if your order of operations is mucked up, it will be very different. Now this equals 70,409.07. 70,409.07. And you can see the difference between question 3A and 3B, there's not a big difference in the final value of that investment. This one's a little bit higher because it has been compounded more often. But that's not what the question's after. I don't want to know the value of the investment, I want to know the interest. So my interest is equal to that number there, what I finished with, minus what I started with, minus the 49,000. So again, back to our calculator, and we just leave what's on the screen there, and I'll say minus 49,000, and that's equal to 21,497. Okay, so a fair bit more complicated. Look at the working for that first one, look at the working for the second one, read the questions, hardly any difference in the wording of those questions, and most of the figures are the same, right, but part B there is a much more complicated question. Okay, question 4A coming up. Okay, question 4A, depreciation. We've got a new car, costs $45,000, depreciates by $6,000 per year. This is a very straightforward, straight line depreciation question. Now, remember that our formula for this is our salvage value, which we're trying to find out, is equal to our initial value, that's V with a little zero there, minus D, which is how much depreciates per period, multiplied by the number of periods. That's my N there. So my salvage value is equal to 45,000 minus 6,000 times 4, right? It goes down by $6,000 per year, it goes down 4 years. 6,000 times 4 is $24,000, take that away from $45,000. In fact, we can do that in our head, can't we? 45 minus 24 is going to be $21,000. Salvage value after 4 years is $21,000. Righto, let's look at 4B, which is a bit more complex. 4B, and by far the trickiest question out of this revision. We've got this boat depreciating by 12.5% of its initial value every year, and I know its value at 5 years old. What was its value when new? Well, I know that it's gone down in value by 5 equal amounts. And if I knew the new value of the question 1, I'd have part 1 answered already. But nonetheless, I could work out 12.5% of the new value, and I know that's what it has gone down by each of those 5 years. What we're going to do is, I'm going to say, for part 1, 12.5% times 5. Right, what does that equal? 62.5, I reckon. 62.5%. So it has lost 62.5% of its initial value. That means that it remains, what remains is 100% minus 62.5 equals, what's that? Oh, not a dollar sign. It equals 37.5%. Right, all that is left is 37.5% of its initial value. It's lost 12.5% 5 times. It's lost 62.5% of its initial value. 37.5% remains. Now we're going to use the unitary method to solve this. I know that 37.5% of some number equals 60,000. So if I do 60,000 divided by 37.5, right, this is going to tell me what 1% is. Calculator's turned off. So 60,000 divided by 37.5 equals 1,600. Okay, is that right? Yeah, 1,600. That means that 100%, my initial value, I've got to multiply that by 100, and I get $160,000. There we go. That's my initial value, is 160,000. Right, well there you go. $160,000. that means it's going down by, we can see fairly quickly, it's dropping by 20%, $20,000 per year. Now, for part 2, how long will it take for the value to fall below $5,000? We could just keep stepping this down. I know that it's, right, if I divide, or if I, actually, no. Let's use our formula. And I'll say that my salvage value equals VO minus DN. Okay, I'm writing this out just because it's a more complicated question. We know our salvage value is going to be 5,000. Now, VO, our initial value, we just worked out as 160,000. Now, D, well, look, let's just go over here. I'm going to say that 12.5 over 100, right, 12.5% of 160,000. We're going to see it's 20,000, right? 12.5 over 100 times 160. Yeah, $20,000. I've actually made my question a bit too neat and tidy. So that's what D is, right? So it's this minus 20,000 times N. Now we'll rearrange this a little bit, and I'm going to say 5,000 minus 160,000. Oh no, let's do it a different way. No, we'll stick with this. Equals negative 20,000 N. That means that N equals, right, 5,000 minus 160,000 is negative 110,000 over negative 20,000. Right, so it's 11 over 2 equals 5.5 more years. Oh, hang on. Something has gone wrong here, hasn't it? Yep. 20,000 N. 5,000. What am I doing wrong? 5,000 minus 160,000 equals 155. Now divide that by negative 20,000. I missed a zero there somewhere. Right, 7.75. 7.75 years. But keep in mind that 5 years have already elapsed. Right, so within the context of the question, right, so it will take approximately 7.75 years from new, which is 2.75 years from now, for the value to drop below $5,000. We might, if we wanted to be very thorough, change that 7.75 years. The 0.75 is 3/4 of a year, which is 9 months. So another 2 years, 9 months. But that's assuming that the depreciation occurs continuously and not once per annum. If that was the case, then we would round it up and we'd say in 3 more years, not only would it fall below $5,000, it would fall to 0. Anyway, that's it for the revision. Hope it's been helpful. See you in class if I don't see you now.